Hello, class. So I understand that there was probably some confusion about how to do cosines and sines and tangents for homework, and I just wanted to go over that and help you guys out, make sure you understand it a bit. I mean, it was pretty confusing for me, so I can imagine that some of you probably aren't having the best time trying to do this. So I'm just going to try to make this nice and simple. So let's say we have a triangle, just a good old right triangle with a 90-degree right angle. Now you have three angles in a triangle. You have, let's name this angle A, angle B, and angle C, like that. The sine, actually no, hang on, before we do that, let's give the lengths, the sides some length. So let's give AC, let's give this 3. Let's give this one right here 4, and give this one here 5. Easy enough. So the sine, we're going to focus on angle A. So the sine of angle A is the opposite, which in this case is 4, because this is the hypotenuse and this is the adjacent. I'm pretty sure you guys can figure that part out at least. Now the sine is opposite, which like I said is 4, over the adjacent. No, sorry, over the hypotenuse. Opposite over hypotenuse, which is 5. So 4 over 5, and this right here is the sine of angle A. By the way, this little symbol here is angle. Looks kind of like a greater than sign, but it's flat on one end, so it's like kind of like that. Okay, the cosine of angle A is kind of like the sine, but instead of the opposite, it's the adjacent. So the adjacent of angle A is 3 over the hypotenuse, which is still 5. This right here is the cosine of angle A. Shoot, no, I don't do that. Cosine of angle A. Now, the tangent is the opposite over the adjacent. So the opposite of angle A is 4. And the adjacent is 3. So 4 over 3 is the tangent of angle A, like so. Now, most of the homework, actually all of the homework pretty much, is based on this general ideology, however you say that. So let's do problem A from the homework. Problem A asks you to find the values of the sine, cosine, and tangent of angle A. So let's draw this triangle here. Angle A is here, angle B is here, and angle C is here. The lengths are 36, 39, and 15. Okay, let's start with the sine. So going back to our first example here, the sine of angle A is the opposite over the hypotenuse. So if we go to our math problem here, the opposite of angle A is 15. Because the hypotenuse is right here. The hypotenuse, by the way, I'm pretty sure you guys know this, but it's always the diagonal, the longest one, hypotenuse. And 36, this one right here, because it's right next to angle A, it is the adjacent, because adjacent means right next to. So that means lucky number 15 here is our opposite. So sine is the opposite over hypotenuse. So the opposite is 15, and the hypotenuse is 39. Now this can be simplified, but you guys can do that. So for now, I'll just keep it this way. 15 over 39 is the sine of angle A. Now the cosine, like I said before, the cosine is the adjacent over the hypotenuse. So going back to here, the adjacent of angle A is 36, and the hypotenuse is 39. So 36 over 39 is equal to the cosine of A. Now again, going back to our first example, the tangent is the opposite over the adjacent. In this case, it was 4 over 3. Going back to our math, going back to problem A here, the opposite is 15. So we put 15 on the top. And the adjacent is 36. 36. this is the tangent of angle A. See, that wasn't too bad, was it? Now, problem B is, hold up a second. Problem B is about the cosecant, the secant, and the cotangent. Pardon my messy papers. But basically, the cosecant, the secant, and the cotangent is, it's just like a good old sine A, but it's the reciprocal, which means that it's like 1 over sine A. It's the reciprocal. So let's the triangle in problem B here. It's written like so, with A up here, B up here, and C up here. The lengths are 20, 12, and 16. So let's just solve for the normal sine. Of angle A, right? Yes, angle A. So the sine of angle A would be opposite over hypotenuse. Like we said here, normal sine is opposite over hypotenuse, which in this case, the opposite is 12, and the hypotenuse is 20. But now, because this is equal to the sine of A, but now because it's the reciprocal, you flip them. It's a lot easier than trying to mathematically divide 1 into all this. So this is normal sine, but 20 over 12 is equal to the cosecant of A. It's just sine, but flipped upside down. It's as easy as that. So let's take the cosine, or also known as the secant. By the way, I don't know whoever named this, but sine becomes cosecant and cosine becomes secant. So I don't know if the guy that made this was dyslexic or evil, but either way, make sure that you know that. The cosecant is the reciprocal of sine, and secant is the reciprocal of cosine. So let's just go for the good old cosine. So the cosine here is adjacent over hypotenuse. So adjacent over hypotenuse, in this example here, the adjacent of angle A is 16, and the hypotenuse is 20. So this is the cosine. Cosine of A. But just like in the first example, to get the secant in this case, you would just flip them. You flip the numbers. So 20 over 16 is equal to the secant of A. It's as simple as that. And so for the tangent, which is just cotangent because tangent's a good boy, tangent is opposite over adjacent. Opposite over adjacent. The opposite, in this case, of angle A is, we're running out of room. The opposite of angle A is 12, and the adjacent is 16. So this is tangent of A. And, all right, I'll just write it right here. And so when you flip it, it becomes the cotangent. So 16 over 12 is equal to the cotangent of A. Just like that. All right. So now we're going to move on to the later problems. The word problems that tripped me up and probably tripped some of you guys up. Actually, this one's not a word problem, but it's close enough. So find the value of x, round to the nearest tenth. This is problem C, by the way. So let's draw this out. You have triangle like so. You have x right here as the hypotenuse. You have 62 as the length of this side, and the angle right here is 15 degrees. Remember that this is 90 degrees here because it's a right angle. Okay, so the way that you would do this, so you have to first look at what the problem gives you. So in this case, you're given in terms of angle A, in terms of 15, we're just gonna 15 right here. Yes, okay. So you have to look at what the problem gives you. You know what? Hold up. All right. out to right here. So when you solve this, you first need to look at what the problem gives you to start. So in this case, when it comes to angle 15 here, it gives us the adjacent of angle 15, and it gives us the hypotenuse. Now, what formula works with the adjacent and the hypotenuse? Oh, well, if we look back at our first example, adjacent of angle A was 3, and the hypotenuse was 5. So that would be our good friend cosine. By the way, don't worry about cosecants and secants for this one or the next ones. It's just these three right here. So you have the adjacent and hypotenuse, so you'd be working with our good friend cosine. So you can write it like this. So cosine of 15 is equal to the adjacent, which is 62, over x. Like so. Now, in order to solve for x, you would multiply both sides by x to get it out of the denominator. So x times cosine 15 is equal to 62. Now, you would divide both sides by cos 15. So x equals 62 over cosine 15. All right. So now is when we bring our good friend, the calculator, into this. All right. So first of all, before you do any of that, you want to go in your calculator, press mode, and make sure that right here it's set to degree instead of radian. You're going to get some real funky answers if it's on radian. So just go down to here, go to degree, and just press enter, and make sure that it's highlighted in black. All right. Now once we have that, we can plug this in. So we do 62 divided by cosine, right here, cosine 15. And we get 64.18, what does it say to round to? Round to the nearest tenth. So 64.18, so we'd round this to 64.2. So x equals 64.2. There you go. You just solve for x, like this. Now the next problem confused me even more. The next problem is a word problem, and I never like word problems because it involves reading, and who likes reading? Alrighty. So a surveyor is located 380.7 feet from the base of the Chrysler Building in New York. The angle of elevation from the surveyor to the top of the building is 70 degrees. Find the height of the Chrysler Building to the nearest foot. Okay. So, let's draw a triangle here. A triangle like so. Now this involves some imagination. So let's say that the Chrysler Building, oh boy, I suck at drawing. The Chrysler Building is right here. Our good friend Chrysler Building. We can add a little top to it. There, Chrysler Building. Okay. What we're given is that the distance between our lovely little friend down here and the base of the Chrysler Building is 380.7. It also says the angle of elevation from the surveyor to the top of the building is 70 degrees. Now this was confusing, but the angle of elevation means this angle right here. So 70 degrees. So we want to look at what we have. Like we did with this problem, we saw that we had the adjacent and the hypotenuse. In this problem, when it comes to angle 70 here, we have the adjacent, which is 380.7, and we're trying to solve for the height of the Chrysler Building, which means that this right here is x. So we have the adjacent and the opposite. So let's go back to our first example here. Out of all these three, there's only one of these that involves the adjacent and the hypotenuse. No, the adjacent and the opposite. Oh, I can't speak today. And that was our good friend tangent. If you remember here, the adjacent, hang on a second. Okay, the tangent is the one that involves both the opposite and the adjacent. In this case, the opposite was 4, and the adjacent was 3. So let's look at our new problem here. What we have here is we have the adjacent and the opposite, and we're trying to find x. So we write tangent of 70 is equal to the opposite, which is x, over 380.7, like so. Now, like we do with solving for just about anything, we would multiply both sides by 380.7 to get 380.7 times tangent of 70 equals x. Now if we bring back our good friend the calculator, 380.7 times the tangent of 70 is equal to 1045.96. And because it tells us to round up to the nearest foot, we'd round up to 1046 feet. 1046 feet. Just like that. And 1046 feet is pretty tall. It seems like it would be the good height of a building. So that's really all about really all there is to this kind of thing. Just remember, this is the most important part right here. I'll go over it again. The sine is opposite over hypotenuse. So opposite is 4 and hypotenuse is 5. So sine is 4 over 5. The cosine is adjacent over hypotenuse. So 3 over 5, because according to angle A, 3 is the adjacent and 5 is the hypotenuse. Tangent takes the opposite, which is 4, and the adjacent, which is 3, and that is the tangent. And this can be applied to finding sides and finding the height of buildings. I hope this video helped some of you guys. Please let me know if you have any more questions. And I'll see you tomorrow. Thank you.